Now let us discuss about subtraction. Subtraction of two vectors, that is vector A and vector B are two vectors. Vector A minus vector B means vector A plus minus B. That means by taking the opposite direction of vector B and adding to A, that gives the result A minus B. Suppose vector A is in this direction, that is vector A, and vector B is a vector in this direction, vector B. Then A minus B means we should take vector B in opposite direction, that is vector minus B. So A plus B, that is, this is the resultant R. So A minus B or A minus vector B is nothing but addition of A and minus of B. Minus of B means vector B taken in opposite direction. Taken in opposite direction. Now let us discuss about position vector. Position vector. Position vector, that means this is a point P, suppose, and this is origin O. The vector drawn from origin to the point P is called position vector of the point P. Suppose we have here our coordinate axis x and y. Another vector is here, point Q. The position vector of Q is OQ vector. Suppose another point is here R. The position vector of R is OR vector. So the position vector of a point is the vector drawn from origin to that point. That is called the position vector. Suppose we have to find out PQ vector, vector PQ. You see here, vector OP plus vector PQ, that gives vector OQ. Using Triangle's law. Using Triangle's law, we have OP plus PQ is equal to OQ. That means vector PQ is given by vector OQ minus vector OP. That is, a vector in a plane PQ is position vector of Q minus position vector of P. So position vector of Q minus position vector of P gives PQ vector. So if PQ is a vector in a plane, then PQ is equal to OQ minus OP, where OQ is position vector of Q minus position vector of P. Now let us discuss the position vector of a point which divides a line segment in m is to n ratio. In m is to n ratio. You see here, position vector of a point which divides in m is to n ratio. M is to n ratio. Suppose here we have origin O, x-axis and y-axis. This is a point P. This is another point Q. Position vector of P and Q. Point R is here. R divides PQ in m is to n ratio. The position vector of P is A. Position vector of Q is P. And position vector of R is C. That is, this is vector A, this is vector B, and this is vector C. So, you see here, let us first find out vector PR. Vector PR. Vector PR is a part of the vector PQ. So, vector PR is equal to m by m plus n parts of PQ. Vector PQ. The total vector PQ is m plus n parts and PR vector is m parts. So vector PR is equal to m by m plus n into PQ vector. Now, in the triangle OPR, we have you see here in the triangle OPR, OP plus PR is equal to OR. That is, we have to find out OR. That is OR, which is C, that is OR is equal to OP plus PR. And vector OP is vector A plus PR is m by m plus n of PQ, or it is vector A plus m by m plus n of PQ. Vector PQ is B minus A. That is position vector of Q minus position vector of P. So, simplifying, LCM is m plus n. So, MA plus NA plus MB minus MA. So, MA cancel. We have the result, that is C is equal to M into B plus N into A divided by M plus N. So, this is the position vector of a point R which divides the line segment PQ in m is to n ratio, where A is the position vector of V and B is position vector of Q and C is the position vector of the point which divides PQ in m is to n ratio. So this is the formula you should remember to find out the position vector of a point which divides a line segment or a vector in certain ratio, that is m is to n. Now let us discuss about the resolution of a vector in Cartesian coordinates. Resolution of a vector. Resolution of a vector in Cartesian coordinates. You see here, this is x and y coordinates. Suppose a vector is like this, vector A. Drop a perpendicular here and you see this is a vector, this is another vector. Vector A is nothing but vector OA this is vector OB plus vector BA, that is vector OA. Vector OB is along x axis and vector BA is along y axis. So if the magnitude in this direction is x and in this direction is y, then you know the vector OB can be written as xi cap. The magnitude along x axis and the direction along x axis. And vector BA can be written as yj cap. Now vector OA is vector OB plus vector BA, or vector A can be written as xi cap plus yj cap, where xi cap is the component along x axis, yj cap is component along y axis or parallel to y axis. So each and every vector can be resolved into two vectors like this. One is along x axis and the other is along y axis. So whose sum is the required vector A. This is called resolution of a vector into x and y axis. So this is the discussion about vector for the first exercise. We should start with exercise